Hello everyone, and thanks for joining us for this week's Solid State Watch. I'm Shannon Davis, the web editor for Solid State Technology, and now let's take a look at the top headlines we've been tracking from October 4th through the 9th. Semiconductor capital spending has increased significantly among pure-play foundries as IDMs shift to fabless, fab-light business models, and as new foundry participants intensify competition among the old guard. The total capital outlays the big four pure-play foundries that are forecast to be $16.6 billion in 2013, which would represent 53% of their combined sales. This far exceeds the industry average of 18% capital spending to sales ratio. The Big Four's capital spending as a percent of final sales is forecast to be 24% in 2013, still well above industry average. ASML and IMEC announced the next major step in their extensive collaboration with the launch of the Advanced Patterning Center. Together, they plan to tackle upcoming scaling challenges due to the chip industry's move towards single-digit nanometer dimensions. The center will be located at the IMEC campus in Leuven and is expected to grow to close to 100 engineers over the next couple of years. IMEC will bring to the partnership its clean room infrastructure with a full 300mm pilot line with extension to 450mm. ASML will support the Advanced Patterning Center by making it available its scanners, metrology systems, and holistic lithography solutions, and by using the center's resources to optimize its offerings for the fab environment. The Semiconductor Industry Association announced that worldwide sales of semiconductors reached $25.87 billion for the month of August 2013, an increase of 6.4% compared to August 2012, making the industry's largest year-over-year growth since March 2011. Sales in the Americas increased by 23.3% compared to August 2012, while global sales in August were 1.3% higher than the previous month's total of $25.53 billion. An alternative to scaling is to expand vertically by thinning, stacking, and interconnecting ICs, commonly called 3D integration. Chip-to-chip interconnections are typically made with TSVs, but some TSVs also have major disadvantages, including relatively large dimensions and thermal mismatch issues. At the upcoming International Electron Devices meeting in December, researchers from Taiwan's National Nano Device Laboratories avoided the use of TSVs by fabricating a monolithic sub-50 nanometer 3D chip, which integrates high-speed logic and non-volatile and SRAM memories. They built it from ultra-thin body MOSFETs isolated by 300 nanometer thick interlayer dielectric layers. To build the device layers, the researchers deposited amorphous silicon and crystallized it with laser pulses. They then used a novel low-temperature CMP technique to thin and planarize the silicon, enabling the fabrication of ultra-thin, ultra-flat devices. For more industry headlines during the week, be sure to follow us on Twitter or like us on Facebook. For Solid State Technology Magazine, I'm Shannon Davis. Thanks for watching and see you next week.